Okay, so in this video I'm going to have a look at the 2020 Higher Level Maths Paper 1, Question 6 for the Leaving Cert. So what we have to do first is differentiate this here, 3x minus 5 times 2x plus 4 with respect to x from first principles. So let's call it f of x, and I'm just going to multiply it out first. So we have 3 2 6x squared plus 3 4 is 12x minus 10x minus 20. So that's 6x squared plus 12x minus 10x is plus 2x minus 20. So this is our f of x. Next thing I'm going to do is f of x plus h. So instead of the x, I just put in x plus h. Okay, so let's just multiply this out. So we have 6 times x squared plus 2hx plus h squared plus 2x plus 2h minus 20. That's 6x squared plus 12hx plus 6h squared plus 2x plus 2h minus 20. The next thing we're going to do here is take our f of x plus h and subtract f of x. So it's all of this here, the 6x squared plus 12hx plus 6h squared plus 2x plus 2h minus 20, and we're going to subtract 6x squared plus 2x minus 20. So let's just do that. We have 6x squared plus 12hx plus 6h squared plus 2x plus 2h minus 20 minus 6x squared minus 2x plus 20. The minus here in front of the bracket will change all these signs. So let's see if anything will cancel here now. We have, we have a minus 6x squared plus 6x squared. We have a minus 2x plus 2x. We have a plus 20 and a minus 20. So we end up here with 12hx plus 6h squared plus 2h. Okay, the next thing we're going to do is divide by h. So we're going to take our f of x plus h minus f of x minus f of x. And we're just going to divide by h. So do the same on the right hand side. 12hx plus 6h squared plus 2h. Divide by h. So what happens here is the h will divide into each of the three terms on the top of the fraction. So h will divide in there once. H will divide in here h times, and h will divide in here once. So what we end up with here is 12x plus 6h plus 2. And the final step then that we need to do is find the limit as h goes to 0 of f of x plus h minus f of x all over h. This is really our definition of differentiation. So we need h to go to 0, so that means h here will go to 0, so we end up with 12x, 6 times 0 is 0, so we end up with 12x plus 2. So that's what we get when we differentiate our original function. And you can see if you do it by rule that that's what we're going to get. So you can just check your answer by differentiating by rule. Okay, so the second one then is where we have h of x is equal to half log 2x plus 3 plus c, where c is a constant. Find h prime x, the derivative of h of x. So let's do that. We want h dash x here. Now, if you differentiate log x, you get 1 over x. So if you differentiate log of x with respect to x, you get 1 over x. Now, we have log of something, so it's going to be 1 over that something, which is 2x plus 3. The half is here as well, by the way, so we put that in. And because it's not log x, it's log of some function of x, we've got to differentiate what's inside the bracket as well. So that's a 2x plus 3. And if we differentiate that, we get 2 over 1. So if we do that, we get, let's see, 2 times a half is 1, or just this 2 on the bottom will cancel with that 2 on the top there. And we end up with 1 over 2x plus 3. And that's it for that part of the question. Let's see part 2 here. We have a diagram and it shows part of the graph of a function h prime x. The shaded region in the diagram between the graph and the x-axis from x equal to a to x equal to 0 to x equal to a. This shaded region has an area of log 3 square units. Find the value of a. So we've got to find a here. I've already done it previously, so that's why I have the answer in here, but let's just run down through it anyway. Okay, so we have h prime x. And we know that that's equal to 1 over 2x plus 3. We have done that already in part 1. So what we need to do to find the area under the graph is to integrate that. So we're going to integrate 1 over 2x plus 3 with respect to x. And we want to integrate it between x is equal to 0 and x is equal to a. So we're told in the question that our answer will be log 3. The area under the curve is log 3. So let's do this integration and solve for a. So let's just do this first. So we have 1 over 2x plus 3. Now we've already done that in the previous question, but or if you take, if you want to integrate 1 over x with respect to x, your answer is log x. Now we don't have a 1 over x, we have a 1 over 2x plus 3. So we will do the same thing. We'll assume that it's going to be log 2x plus 3. If you differentiate log 2x plus 3 with respect to x, you get 1 over 2x plus 3. But because it's not log x, it's log 2x plus 3, you'll also get an extra 2 multiplied here. Now we don't have an extra 2 here, we don't have a 2 here, we just have 1 over 2x plus 3. So we've got to get rid of that 2. How do you get rid of that 2? We put a half in here. And that's what we had in the previous question. So our answer here is a half log 2x plus 3. Now we've got to integrate between 0 and a, and we know that our answer is log 3. So let's just make this equation then by substituting in the a and the 0 instead of x. So we've got half log 2a plus 3 minus a half log 2 times 0 plus 3, and that's equal to log 3. Next thing I'm going to do is just multiply across by 2 to get rid of the halves. So I'll have log 2a plus 3 here, minus log 2 times 0 is 0, so I just end up with log 3 here. And I just end up with 2 log 3 on this side. So on the left-hand side, I've got the log of 2a plus 3 minus the log of 3. So what I can do is use the laws of logs. So I can do 2a plus 3 divided by 3. I just divide the two things I'm getting the logs of on the left-hand side. On the right-hand side, I can take this 2 and bring it up here. So that gives me log 3 squared, which is just 9. I have the log of something equal to the log of something, so therefore I can just let those two somethings be equal to each other if you like. So 2a plus 3 divided by 3 is equal to 9. Multiply by 3, so I get 2a plus 3 is equal to 27. And that gives me 2a is equal to 24. That finally gives me a is equal to 12. So that's my final answer here, and that's what I had originally worked out. A here, this one up here, this here is equal to 12. So we integrated from 0 to 12. And that's it for this particular video.